So hello everyone, hello YouTube. So just so you know, everybody, you're on YouTube. No worries, there's not gonna be a ton of people watching you, so still behave though, please. Day 13. So, transparent origami. You reach another volcanically active part of the cave. I'm not just for YouTube. Bye, Toggle. Thank you again. So it would be nice if you could do some kind of thermal imaging so that you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. Nice. When you activate it, you're greeted with "Congratulations for your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual." Well, this could be worse. I think if you do something like this, hey Specs, hey, is this Adam name? Adam name. Well, hello to you too. So this is not even the worst, right? If you get something like, if you buy something new like nowadays, it will tell you you need to log into, you need to register on the website. Oh, Adam name, I see. So you need to register this thing on the website for it to work, and that would be worse. So putting in a code from the page 1 of the manual is not that bad. Like, imagine you get a juice error or whatever. Okay, so apparently the elves have never used this feature. To your surprise, you manage to find the manual. As you go open it, page 1 falls out, and it's a large sheet of transparent paper. What? Okay. The transparent paper is marked with random dots and includes instructions on how to fold it up. Your puzzle input. So, for example, blah blah blah. The first section is a list of dots on the transparent paper. Oh my god. This is the exercise with like geometry and transformations, and if you mess up the orientation of any of your transformations because you forget where the x and y axis should start and go towards, you mess everything up. So this is already scary. Okay, in any case, so the first section is a list of dots on the transparent paper. 0, 0 represents the top left coordinate. The first value, x, increases to the right. The second value, y, increases downwards. So the coordinate 3, 0 is to the right. By the way, I love putting y on the outer thing, so that's already gonna mess me up. But okay. So the coordinate 3, 0 is to the right of 0, 0, and the coordinate 0, 7 is below 0, 0. Okay, the coordinates in this example form the following pattern where pound sign is a dot on the paper and dot is not a dot. Okay, perfectly clear. Then there is a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal y equals dot 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 lines, or left for vertical x blah 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 lines. In this example, the first fold instruction is fold along y equals 7, which is here, which designates the line formed by all the positions where y is 7, okay. Because this is a horizontal line, fold the bottom half up. So basically, what it's asking you is to overlap, but also rotate in the right direction. Or not rotate necessarily, mirror, flip. I mean, yeah. So some of the dots might end up overlapping after the fold is complete, but dots will never appear exactly on a fold line. So the fold line, you know, it's empty. You don't have to worry about corner cases there, I guess. The result of doing this fold looks like this. Now, only 17 dots are visible. Okay, so basically the number of dots is reduced it's either equal or lower because of overlaps. Notice, for example, the two dots in the bottom left corner before the transparent paper is folded. Bottom left corner, these two, before is folded. After the fold is complete, these dots appear on the top left corner. Yes. Because the paper is transparent, the dot just below them in the result at 0,3 remains visible as it can be seen through the transparent paper. Also notice that some dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is fold along x equals 5, which indicates this line. Because this is a vertical line, fold left. The instructions made a square. The transparent paper is pretty big, so for now, focus on just completing the first fold. After the first fold, in the example above, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. Wait, what? 17 dots are visible. Dash? Dash dots? Okay, okay, I think it's fine. So how many dots? Oh, sorry. So how many dots are visible after completing just the first fold instruction on your transparent paper? Okay, let's code this up. I think this is another example where starting with this seems a good idea with the example input. So, I made the folder, I made day 13, but I didn't touch my input, and I didn't touch my main.z either. Okay, day 13, input. Of course, I didn't copy. Who knows what I'm gonna paste there one of these days, huh? What I want is also, this wasn't saved. What the heck did I commit? I hope I didn't commit. Oh, wait. What are these things? This isn't like necessary. This isn't necessary either. This isn't necessary either. Okay, so there's a bunch of garbage from when I was explaining stuff yesterday. I'm gonna steal this for day 13. I think we can close this, we can close this. Okay. So we have our input, we need to start parsing it, right? So I think we need to split on what do we do here? What's a good way? I'm trying to think about a nice way of expressing this with tokenize. So I would say new line and comma. The problem, if I use tokenize with new line and comma, so I can kind of, okay, I think I can kind of cheat. Well, not necessarily cheat, but like, okay, I think I know what to do. So, comma, new line and equals. Let's go. I love abusing tokenize. So we split bytes, it's our input, and our separator is gonna be new line, comma, equals, and that's it, I think. Let me double check. Comma, new line, equals. Yes. So, thank you for the follow, Internet Bird. IT is my iterator on the input. Also, I'm cheating because for people that come from ToggleBlitz stream and maybe don't know what the heck I'm doing. So I'm also cheating because I'm embedding the entire input in my executable, because I can do this with embed file. If I wasn't just making basically a one-shot program just to get the solution and then never use it again, I wouldn't do this, right? I would probably want to get as input a path that points to the input, and then I open the file, I read it, blah, blah, blah. But that's not what you do in Advent of Code, right? In Advent of Code, you only care about the answer. So I'm cutting some corners there. I'm not doing good software engineering, or because that's not the goal, right? So I'm trying not to do too many horrible things, but occasionally I will cut corners. So here I'm iterating over every token that Tokenize gives me, and Tokenize splits the input every time it encounters any of these characters defined in here. So what it will give me is gonna be a number, then a number, then a number, then a number, then a number, except when the first thing that we get is this. Because we're also splitting on the equal sign, right? So when we're splitting on the equal sign, also Tokenize doesn't give me empty string tokens. Lord Shroomy, I think you deserve to a bit more time in timeout. What do you think? Okay, so if I get this as my first token, then I know that I'm not parsing this part anymore. I'm parsing a different part, and I can tell because it starts with F. Even just having my token start with F. This is not responsible parsing, as you can probably imagine, right? This is just correct because this is good enough for Advent of Code. But as I was saying, I'm not doing solid software engineering because there's no requirements around that. So everything that I would try to do in a nice way, easier to show off my new, I think that's Borg, yeah, my new Borg features, yes. That's funny. This is the one stream where when somebody misbehaves in chat or like it's a bot asking for like offering fake followers, they are actually helping the stream. They are helping me showcase Borg. I need to make a release of Borg so actually other people can use it and not just me, or like people that are deep into the Z community. So let's immediately start counting for this case so that we know what's happening, right? Or let's do it, or rather, let's filter out this case so that we can immediately handle this. So I can do it like this, I think. If talk 0 is different than F. So if my token doesn't start with F, I know I'm in the first few cases. So in the first few cases, I'm getting the coordinates, right? So it's gonna be chord. Also, wait. Next question: How do we store that information? Transparent paper, yes. So these dots are, in a way, they're describing a matrix. We could make a matrix, and maybe there would be some good reasons to make a matrix, but I think that given how sparse this is, on a hash map is better. And then instead of like moving bytes around and then applying bitwise operations, we probably just want to apply the correct transformation to each coordinate. So like as the exercise was saying, these two dots down here go, where is it? These two dots down here go up here. And basically what we want is, I don't know what this is gonna be, 10 on the y-axis, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14. So this is gonna be 14, 14 becomes 0. So basically, when you flip around, you need to do that correctly. You don't subtract 14, I think it's different. You do 14 minus the y coordinate or something like this. So I think this is the right way of approaching this problem. So let's steal some hash map code. Am I gonna do a string hash map? No, I think I want a auto hash map. I don't know how to call it. Space, dots. So keys are gonna be what? Well, a key is going to be I could make it like this, an array of two. I don't know how big are these numbers going to be. These numbers are really small. Are my numbers also going to be really small in my puzzle input? Not that small. Oof. Okay, so this is like, they all go up to, they go past 1,000. 1272, so like these numbers go up a bit. Okay, let's do I32, I guess. Let's do I32 so that we don't have underflow problems. And the values are going to be void. Like, we don't need values, we basically need a set, I guess. Although, do we even really need a hash map? Now that I'm thinking about it, I think an array list is good enough. Because you want to apply transformation to the numbers. Oh, but then you need, how do you... No, wait, no, you need a hash map because you need to squeeze together points that end up in the same coordinates. So I think this is okay. Unless, you know what? I'm putting a bool there. I'm putting a bool in case it comes handy later on. Okay. Init this with an allocator, and we're good. So the idea of the boolean is that I think that when I'm folding stuff, I don't want to remove the point from the hash map. I think I want to leave it there and turn it off. The reason for this is because I probably will want to iterate over the entire hash map once, and I don't want to apply side effects to it as I'm iterating. I could probably do it. So I'm leaving myself the possibility for now. That's why I'm doing it. So I don't know. My element chart application wants to update itself. Okay. Let's see. For what it's worth, underflow is a bug in the solution. You could use unsigned to catch that. Yeah, but I think that IAs, I don't know. I don't know. We'll see. I mean, that's absolutely fair. The problem is that it's when I'm trying to come up with other coordinates that I hit a underflow, and then it's annoying because it's a panic, and I need to add checks before that. But maybe, I mean, you already written this, so you know how annoying that is going to be in this case or not. Well, I'll keep that in mind. I'm assuming that you're probably right, so I'll keep that in mind. Okay, so let's get the coordinates and let's put them in the hash map. Also, I hope that this works because I'm not sure if the auto hash map is going to automatically correctly come up with a function for this. I think it should, but I don't know for sure. like with a hashing function and equality test function. It will. Nice. Remember to enable the GPA to catch memory bugs. Yeah, well, in this case we are leaking without. Yep, we are leaking. Okay, so token is the first coordinate, right? So we need the second coordinate. Or rather, let's parse it. So const. We said that the first coordinate is the x, right? So x is going to be std.fmt. Actually, no, yeah, I need to do this. std.fmt.parseInt. We are parsing what? A I32. Talk is our token, and the base is 10. Then y is basically going to be the same, but from it.next. Also the double T. I don't know what's up with this keyboard. So we parse both numbers, and we got both coordinates, and now we add them to the hash map. So dots dot put, also try, because this can allocate. So we put what? X comma y, and as value true. We repeat this. We repeat this multiple times. So we, at the end, we are done. We parse everything. Then we get to the point where we start parsing these lines. Need to try parsing it as well. Yes, good point. Okay, we get here. So we know that this thing is gonna end in either y or x, right? This is what we need. Also, you need to unwrap. Yeah, good point. Thank you. Yep. Okay, so we're in the other case. So we need to find the axis. The axis is going to be talk.len -1, and it's going to be either x or y. Then we need to parse once more to get the coordinate. Or I think coordinate is not the correct name, right? A coordinate requires both. What would you call a partial coordinate? Partial coordinate. Okay, I guess that's maybe one way of doing it. Whatever. I'm gonna use okay, partial coordinate it is. So the partial coordinate is going to be it.next unwrapped. Oh, I need to also parse it. So it's basically this. There we go. Okay, so this is where the interesting part happens, right? Because now we have to apply this transformation. So, applying this transformation means going over every single dot in my hash map and going over every single dot in my hash map and transforming it based on a rule. So for I think I need an iterator, right? So for coordinate iterator is going to be dots dot what? Hey CodeMonk, I don't remember how you call the iterator on a hash map. It's funny because I'm using hash maps so much and I keep forgetting. A function iterator? What do you know? So we found the iterator, and while. So there's a key iterator, there's a value iterator, then there's get or put adapted. Okay, so basically, while there are more points to find, for each one of those, what do? For each one of those, we want to, if it's above / left of the line, do nothing. Otherwise, flip. And we need to make sure that we get the flip equation right. So, okay, yeah, if it's above / left of the line, so we need to, I guess, switch based on which axis we are iterating on, right? So let's switch axis. And if the axis is Y, we're gonna do one thing. And if the axis is X, we're gonna do another thing. Else, it's not really a possibility. No, not semicolon there. Then, okay, it's Y. So if it's Y, also, JD LaFontaine, thank you for the follow. Welcome to the stream. So if you are flipping over the y-axis, so if the y coordinate, which is the second one, so P2, sorry, P1, if P1 is, and we're saying that top left corner is 0, and as we go down is it increases. So if it's greater than partial coordinate, it's only then that we do things. So what do we do in that case? We keep the x coordinate untouched, and we flip the y coordinate. Whew. More Borg feature showcase, huh? Isn't it? KMRT 80. It's fine, I don't need soap. So P1 greater than partial coordinate. We need to flip the y. Flipping the y means basically creating a new point where also the P, wait, I'm not getting P actually, I'm getting something else. I'm getting an entry. This is going to give you an entry, so let me double check this. The iterator pub count, actually I can do this. Pub function. Your beautiful Apple emojis are gone. Oh no, you're right. Oh no. The skull is pretty nice. They actually are nice, I agree. Yeah. Life is tough. Okay, so the iterator, when we do next, it gives us an entry. So now we need to find where an entry is, okay? Pub const entry. Or no, I think it's a function. Or is it? It's not a function. Okay. All right, because it basically closes over the generic arguments. Right, so this is an entry. We're gonna get key pointer and value pointer, which means... Wait, what happens if I modify the key pointer? What happens to my hash map? I should probably not modify my key pointer, should I? Can anybody tell me Specs, are you still here? What happens if I modify the key pointer? I should not do that, right? You can install the app. Wait, can you actually really? That would be cool. So can I modify my keys? What happens if I do that? So what does get say? The key in the map. It doesn't really say if you can do that or not. You can modify the key pointer as long as it doesn't change the hash. Okay, so you kinda can't. Or rather, okay, I see your point. That's very clear. You can modify basically all the properties that aren't indexed by the hash map, or like that the hash map doesn't care about. So they are, or rather, they are used for uniqueness. So long story short, we can't modify the key. That makes sense. That's what I assumed, but you know, I was given a mutable pointer, so the temptation is always there. So we make a new coordinate, I guess. So this P1 is gonna be entry. Oh, okay. Entry dot key underscore PTR. I think I need to do dot star. I cannot immediately do square bracket 1 because I'm given a pointer to the array. Actually, I take this back. I think I should be able to do this because when you have a pointer to an array, you can do this. Yeah, so this should be fine. Okay, so we need to make new y, right? Const new y is gonna be this. How's it gonna be? So we were saying if your y coordinate is 14, it has to become 0. If it's 13, it has to become 1. So it's basically 14 minus that, right? But what the heck is 14? 14, we know 14 from the example. On array hash map, there's a function you can call to rebuild the index after modifying the keys and changing the hashes where it will not remove duplicates. I see. What's this 14? We know 14 from the example, but we don't know what 14 is from this, and I assume we basically have to store the maximum y that we find and assume that that's our end of the paper. Which I think it's funny because it's a bit so isn't it a bit slightly undefined? Like you could have a big piece of paper where the dots don't go, like you don't have any dot, I don't know, for like a few rows, but they are still part of the paper, and when you fold up, you're also supposed to account for that. And I'm not sure that keeping track of the maximum y value that we encounter is, I mean, I think it is the only thing that we can do, so we're gonna do that. But it seems to me like it's a small angle that the exercise could have explained better. Or maybe it did, and I just didn't realize that. Isn't every fold down the middle? So isn't your fold instruction hinting you the size? I don't think so. It says it when it specifies the fold, it also specifies the coordinate. So is the coordinate also the middle? Does it say that? The max can't be larger than the fold point. Yes, not always exactly at the middle. But it doesn't matter, you won't get negative coordinates. Well, my worry is not negative coordinates, is... Let me think about this. Oh, right. Wait. Because, wait a second. Wait. So, I was thinking of doing 14 minus this coordinate. But it can be done in a better way. It can be done as 1, 2, 3, 4, 5, 6, 7 minus 1, 2, 3, 4, 5, 6, 7. So the cutoff coordinate minus twice of this multiplied by 2 minus this, maybe. So partial coordinate times 2. Like this. Let's see. Because so maybe we don't know how big everything is. But yeah, but we know the cutoff point. So that's what we need to use. That makes sense. So yeah, we do the first 7. Multiplied by 2 gives us what needs to be the 0 for sure. So that seems reasonable. Also, should I worry about 0, starting from 1? No, they start from 0. It said the top left corner is 0, 0, so this should be okay. Oh, I don't know. Well, let's see how it goes. So this is gonna be our new y, and then so we set this entry to 0. So we remove this entry. So entry dot value pointer dot star equals false. And then we create the new coordinate. Maybe this should be done up here. So we set it to false. Then we create the new entry coordinate, and then we use that to create the new entry. So we do... Ooh, but here's the problem. Okay, here's the problem. I want to add stuff to the hash map, but I think that adding stuff to the hash map invalidates our iterator anyway. So all this care about not eliminating dots, it's kind of wasted, I think. The iterator is validated if the map is modified. So we need to apply set effects to it anyway. So who cares about this? This is going to be void. We don't set anything to anything. What we do is, which is annoying, which means that basically we need to recreate the iterator every time we iterate. So I guess that's what we want to do. Wait. That's dumb. That's not what we want to do. Wait. Oh no! What is it that we want to do? We need a second hash map, is that it? Yeah, we can't really do it in place, can we? We could if we had a hash map that allowed us to iterate to it to the end. Which is funny because there are some hash maps that allow you to iterate them for sure once, without skipping any element, even if you're modifying them in the meantime. But we don't have that. That would be a neat implementation to have. I guess I need a new hash map. I need basically two hash maps, right? I have the old one, and then that I iterate normally. I don't delete anything from it. I just keep iterating over it until I consume it entirely, and then I have a new one. And that's the only one. So at this point, does it even matter that it's a hash map? No, I just need to erase at this point. Life is tough. Yeah, I need to erase because... Wait, do I... No, I still need to deduplicate because I could have one dot that doesn't move, another dot that moves, and it should go... And it basically overrides the other one. But actually, I know that I don't need to add this new point because I can test for it in the original thing. You know what? Two hash maps it is. Two hash maps it is. So here's what do we do. Do our dots temp is the same. We iterate on our normal dots thing. We create a new coordinate and you know what we can do? We can do this. Var chords is gonna be entry dot key pointer dot star. So we copy the coordinates here, and if this is the case, we change coordinates 1. So we change the y there, and regardless whether we did any change or not, we add that to our dot stamp. And actually, this could go out here. This could go down here. So we always copy over the coordinates. We modify the y in this case. We kind of do something similar for the x. So if x 0 is greater than the partial coordinate, then coordinates 0 is gonna need to be the partial coordinate times 2 minus that. Wait a second. So we can do it like this. Oh, wait a second. Are we assigned to coord and referring? It's fine. So coords 1. I don't know why I copied chords again. Okay, does this make sense? Kinda seem to make sense a little bit. So we put in the new coordinates that we just modified. And then once we're done with this process, dots, we need to basically free. So we the init dots, and then we do dots equals dot stamp. I should leak it and not even the init. And so now we have our new version. I guess. And then what you wanted to do at the end, just count the remaining dots, right? So how many items we have? Which is, how do you count the items in the hash map? Public function count. That makes total sense. So at the end, once we're done doing all this stuff, sd.debug print dots dot count. So where do I declare dots just to make sure that it survives the while loop? Yes, it definitely survives the while loop. So this seems fine. Now let's see the compile errors. Okay, found bool. Fair point. I had a boolean value here, and instead I need to put the value void, right? Void is my type for values, and void has a value which is this. It's an empty block, or rather whatever the empty block returns once evaluated. Also here, when we put coordinates, we need to put void, and I think we're good. Result 16. 17 dots. Off by one. Of course. Of course, off by one. I need to check for negative coordinates. That's a good point. And now I see the point. I do subtraction, but it should never go negative. That's fair. So let's go to unsigned. Let's hope that Zig doesn't annoy me too much about unsigned subtraction. Result 16. So we are not underflowing, but something is wrong. What could it be? That smells a lot like an off by one error. Also, you know what? Maybe it's worth printing the dots at this point. So how am I gonna do this? Var I without usize, I guess u 32 equals 0, while I is lower than I'm gonna be the one who decides that. I'm gonna do it manually, so like, what is it? I, oh wait, instead of I and j, let's do x and y. So while x, also, do I want x on the outer thing? No. Yes. No. I think I want y on the other thing, do I? So while y is lower than, I don't know, we said it was 14, right? Or whatever, let's do 15. Y plus equals 1. Var x u32 equals 0. While x, we can do 16 for x also, I guess. It's smaller than x is just gonna be 2, 4, 5, whatever. So let's go 6. So if dots dot contains if dot contains what, x comma y, then we std debug dot print what? Oh, you know what? We're gonna print stuff either way, and then we assign to stuff string in the if b. So b is gonna be, oh my god, like, okay, I have equal sign in the T key. The T key is going crazy today. I don't know what's up with it. So v equals if that contains blah blah blah. Oops. What was it? Pound sign. Otherwise, dot. And when we're done with our rows, we print a new line. And that's it. And let's see how it goes. So that seems to be the same. Oh no, you know what? Wait, what? I'm confused. It's a square with a 3x3 empty space in the middle. It's a square. Oh, actually, I don't know if it's actually a square, but it's rectangular enough. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's actually really a square. Yeah, of course, because it's 3x3 the content. So what? Sorry, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. What am I missing? Why does it say 17? Oh, wait. I think it's 17 after the first fold. Right. I applied both folds. Oh, yes. Right, it's the second fold that I guess brings it down to 16. Right, let me do it only once. So let me do that. If we go in the case. Wait, can I do this? Okay, so this is a very dumb idea. I don't do this at home, but can I do? Is this legal? This is not legal, is it? Okay, cannot break out of the first version. That's fair. Okay, so we do this once, and once we get at the end, we just do a break. So we only run the first thing, and the result is 17. Okay, I was going insane, man. So the problem is that we basically applied more than one rule, and we just want to apply one rule. Yes, only the first instruction. So how many dots are visible after completing just the first fold instruction in your transparent paper? Okay, let's see what happens with our proper input. So proper input, do I still have the break in place? What am I looking at? This. Yes, the break is in place. Okay, run. Result 671. Yes, our printing code is not really going to do it correctly for the actual space that we're using. I don't know, is this it? Yes. Finish folding transparent paper according to the instructions. The manual says that the code is always 8 capital letters. Wait, what? What code do you use to activate the infrared imaging camera system? Oh shit, now we have to print it actually. Oh my god. Oh my god. So now we have to run everything, but we don't count anymore. We need to print it. So here's how we do it. We don't do result anymore, so let me just do it. Yeah, okay. Oh, it's not that big. Okay, I thought it would be like giant or something. So let's widen it. What's the X going to be? I don't know. They're not going past 80 columns. They're not going to go past 80 columns, are they? P C P H A R R K L. Oh my god, PCP, my eyes are going together. Is there anything better that I can put inside of that thing? So a pound? I think the pound sign is one of the best though, isn't it? Oh, you know what I can put? this isn't helping much. Oh, also because it occupies two thingies, so I think I need to do it like this. Oh, there's also the problem that some things are not okay, so let's do 60. 40? Oh, it actually helps. PCP HAR KL. I think I also remember the rest. FCK GW RH QQ. What was it? QQ2. I don't remember the rest. Those who know what I'm referring to. Those who don't, it's fine. Okay, today wasn't particularly bad. That was a fine exercise. Nice. I feel less dumb. Nice touch with the lightning bolt. Thank you. It actually did help. But since it occupies two columns, you need to account that also with the dots. Nice. Okay, and with this, I think I'm done with today's Untitled Code. I hope everybody enjoyed it. Is anybody Windows serial number? Daniel, you know what's up. Yes, that was the Windows XP serial number that I think everybody used for the backup copies of XP. Of course, everybody also had an original copy, like an original license key somewhere. But yeah, that was the Windows XP serial number everybody used, and I think that there are like some messages in that serial number. I'm not sure, but yeah, good times. Okay, so does anybody have any question about the resolution or any Z question in general? Let me see if I can make any comment. Did I learn anything interesting today? So Specs was 1000% correct with leaving stuff unsigned. No doubt there. Tokenized, once again, proved useful. You don't necessarily have to do this trick here. You can also do maybe something where once you encounter this case, you break from a first while loop and you enter in a second one. The problem is that once you enter the second one, you will have a one-off problem where the current token that you have already consumed is the one that you need to start using in the while loop. So in the second while loop, basically we'll need to use that value and then grab the next token at the end of the while loop. It's kind of weird. So I just ended up doing this. Again, not good engineering, but reasonable shortcut for the purposes of Untitled Code. There's an empty line first though, no? Yes, but the problem is that this empty line doesn't show up in Tokenize. Tokenize doesn't give you null string tokens, which is useful in other situations, but in this case, yeah, it did not. There is another function in the standard library that does give you empty strings if necessary, and that's split. But the problem with split is that, or rather the problem, I wouldn't say it's the problem, but what makes it unsuitable for this case is that split doesn't it takes in a list of characters, but the list of characters is not or, so it's not any of these characters like it is with Tokenize. In Tokenize, we were splitting on any of these. With std_mem.split, if you pass in a string with like multiple characters, split will search for that entire string in the input and use that entire thing as a separator. So like, for example, if you have like number, arrow, number, you can do split on the arrow, and split will consume the entire arrow. While if you put the error inside tokenize, tokenize actually will also consume the error, but as a side effect, because it will consume first the first token, then it will return you what's left of the dash. Then it will consume the arrowhead and produce an empty string, because there's nothing between the dash and the arrowhead. Will not return it to you, so it will continue again, and then will give you the second, like whatever is at the right side of the arrow. So it will actually produce the same end effect in that case, but it's I would say it's kind of like a coincidence. You kind of don't want that, I think. And so as I was saying, with tokenize, then I had to do this trick. And a cleaner way of parsing this would have been to split by lines. Like the saner way would be you split by lines, and then you start by assuming that you can then split every line with a comma, and when you encounter an empty line, then you start splitting on an equal sign, or something like that. That's absolutely fair. I just got into the habit of, as I was saying in the beginning, abusing tokenize a little bit, and like using it, like coming up with a superset of all the separators that I need, or rather like the union of all the separators that I need, and then hack around the final solution. I would not recommend that if you're serious about parsing, but also if you're serious about parsing, obviously not only you don't do this, but also you need to somehow make sure that you don't make all the same assumptions that I made. Also be careful that by using tokenize, which for sure did not give me empty tokens, I was also sure that I could do this. If you're using split, you cannot do this blindly. You need to make sure that there's gonna be something there. In any case, you can see how this pace is kind of fuzzy, because we are not trying to do the robust thing. We're just trying to do what the minimum amount necessary is done to actually parse correctly this one input, or at least that's what I'm doing. So yeah. Anyway, that was it for me. So I think we're good. Not bad. I should put this in the thumbnail. So everyone, take care. Let me see if I can rate somebody, and I'm going to do my other stuff. I think I have a meeting coming up, so bye bye, and see you soon, maybe tomorrow. Enjoy a nice JI stream.